Hi students, how are you today? Welcome to Top Tutors, Toppers, e-learning classes. Understand every single concept and be a topper. Today we are discussing 10th grade Cbse Mathematics, chapter number 1, Real Numbers, example number 10. Prove that 5 minus root 3 is irrational. So we have to prove irrationality. As we discussed the previous classes, we have to use contrary methods, contradictory proof by contradiction. So we assume that since they have 5 minus root 3 is irrational, we will start with an assumption, the wrong assumption that 5 minus root 3 is rational. Then we will write 5 minus root 3 in their standard form. Standard form of rational number is what? P by Q, where P and Q are integers and Q not equal to 0. P by Q, where P and Q are integers. PQ belongs to Z and Q not equal to 0. Also, we will assume that P and Q are coprimes. What do you mean by coprimes? The simplest form by dividing by all common factors. We are dividing numerator and denominator by HCF, highest common factor, and P and Q has only one as a common factor. Then we can say that P and Q are coprimes. Okay, and then what is the next step? Then we will argue that 5 minus root 3, we will rearrange in a form that root 3 equal to a rational number. Since the RHS is coming as a rational number, then LHS also should be a rational number. It means we are getting root 3 as a rational number. Actually, this is a contradiction to the fact that root 3 is rational. So we can conclude that the given 5 minus root 3 is irrational. Okay, let us do by step. Okay, so first step, what you have to do? We have to do that 5 minus root 3, assume that 5 minus root 3 is rational. So by 7 steps, we will do this problem. We will solve this problem very easily. First step, let us assume that 5 minus root 3 is a rational number. We are just assuming 5 minus root 3 is a rational number. Actually, this is a contrary assumption, wrong assumption. What is the next step? We are writing 5 minus root 3 in the standard form of rational number. What is that? 5 minus root 3 equal to P by Q, where P and Q are integers. P and Q are integers and Q not equal to 0. And also let P and Q are coprimes. So we assume that we have written 5 minus root 3 equal to P by Q, which is the definition of rational number. And we are assuming again, we are considering P by Q as coprime. How is it? By simplifying to the lowest term. Is there any common factors that are there? Just divide it and make it a simplest form. So P by Q are coprimes. Okay. So third step, just rearrange. Make root 3 as the subject. For that, what you have to do? Bring root 3 minus root 3 to the right side and P by Q to the left side. So next step, when you're doing that, what will happen? See here we are taking this minus root 3 to the right side. So it will become plus root 3. And P by Q we are taking to the left side. So plus root P by Q when you are taking to the left side become minus P by Q. So this equation can be transformed to 5 minus P by Q equal to root 3. This gives 5Q minus P by Q. How will you get this one? We'll take the common the denominator 5 as 1. Okay, 5 by 1, and we can take the LCM. See, I will show you by writing. So we'll just consider this as 5 by 1. Okay. After that, we are taking the common, the LCM of 1 and q as q. What is the next step? The first fraction's denominator 1, how many times goes in q? So it is q times. In any number, 1 goes the same number times. So in 5, how many times? 1 goes 5 times. Same logic. 1 in q times. Q multiplied by 5. So you'll get 5q. Okay. Now second fraction, there is p by q, denominator q. How many times goes in q? 1 time, right? Any number, the same number goes 1 time. So that multiplied by p equal to p. So we are getting 5q minus p by q. Or we can use any method that we can simplify the two fractions, subtraction or addition, into single fraction. Also, we can consider as a equivalent fraction by making the denominator same. For that, what we can do? We can multiply the numerator and denominator by q. That also we can do. See, when you are multiplying numerator and denominator by same number, there is no change. So we'll take the common denominator as the common denominator here. We are taking as the denominator and doing the operation on the numerator, 5q minus 5. So that is equal to root 3. Both way we can do. Okay, fine. Now what is the next step? Next step, we are saying the truth that our LHS, in this expression LHS, 5q minus p is a rational number. 5q minus p by q is a rational number. By the reason, numerator is a integer, denominator is also integer. An integer by another integer, an integer upon another integer is a rational number. 5 is an integer, p is an integer, q is an integer. The numerator is an integer, denominator is also an integer. So this is a rational number. Undoubtedly, we can say this is a rational number. See, if in this equation, if LHS equal to is a rational number, then RHS should also be a rational number. So that argument we are going to do in the next step. So therefore, root 3 is a rational number from 3 and 4, from this statement and this statement. This statement says that 5q minus p by q equal to root 3. Second statement, this LHS part, this is a rational number. So if the LHS left hand side is a rational number, then RHS right hand side also has a rational number. Then only it will be equal, right? So root 3 is rational from 3 and 4. So actually this is a contradiction, right? This contradicts the fact that root 3 is irrational. We already proved in the previous classes, root 3, root 2, root 5, all these are irrational number. But we got, according to our wrong assumption, we got root 3 is rational. So this contradicts the fact that root 3 is irrational. What is the reason? This contradiction has arisen because of our incorrect assumption. Okay, so seventh step, therefore 5 minus root 3 is irrational. That is our conclusion. So hence we have proved that 5 minus root 3 is irrational. Okay, done? Clear? Very easy step, right? Just remember these 7 steps to do it properly. Okay, learn well. See you in the next class. Bye.